Hey everyone, thank you for joining me. Today we will be discussing foiling, a method that allows you to expand an expression like the one that you can see on my screen right here. So, the distributive property works well for simple expressions, but what happens for a more complex example like this one? Well, each term from one pair of brackets is going to multiply each term from another set of brackets. And we can see here that the FOIL acronym breaks down to F standing for firsts, followed by outsides, insides, and lasts. So if I were to put arrows as displayed on the screen here, what I would get is an arrow going between A and C that represents firsts, then an arrow going from A to D that multiplies the outsides, and from B to C we can multiply the insides. Finally, from B to D we get our outsides, and that's exactly what is outlined right here. So similar to what we did last time, I would like to begin with an example that focuses solely on numbers. So here you can see we have 1 plus 2 in the first set of brackets, and 3 plus 4 in the second set of brackets. Now, there are two ways to do this. The first way is obviously going to be to add the numbers. That's probably the most intuitive thing that comes to mind. So here we're going to get 3 times 7, which is going to be equal to 21. But let's take it the other path now. Let's say that we're going to do it by foiling. Well, 1 plus 2 times 3 plus 4, because remember, that's what having two brackets right beside each other means. It means that we're multiplying them. It means that we're going to get 1 times 3 to start, followed by 1 times 4, followed by 2 times 3, followed by 2 times 4. And then we're going to add everything together. Well, this is going to give us 1 times 3 plus 1 times 4 plus 2 times 3 plus 2 times 4. Or in other words, 3 plus 4 plus 6 plus 8, which is going to give us 7 plus 14, or 21. So like you see here, we are getting the same answer whether we add them first or we use foiling. So now I would like to try this example right here. As you can see, this one's a bit different because it involves x plus 1 and x plus 2 as my terms. Now, because x and 1 and 2, which are numbers, are not like terms, we can't simply add them here. Rather, this is a case where we strictly have to use foiling to solve. So it's going to be the exact same process. Start by multiplying x and x, then x and 2, then 1 and x, and then 1 and 2. Well, that's going to give us x times x plus 1 times x plus 2 times x plus 1 times 2, or x squared plus x plus 2x plus 2, or x squared plus 3x plus 2 as our final answer. Okay, so I would like to follow that up with this example right here, x plus 3, x minus 3. And this is really just to showcase that positive and negative numbers both work fine in foiling. It doesn't really make a difference. Okay, so same process as always. We're going to go x times x times negative 3 here, then 3 times x, and 3 times negative 3, which is going to give me x times x plus x times negative 3 plus 3 times x plus 3 times negative 3. And if it helps you conceptualize it better, you're welcome to put the negative 3 in brackets. Doesn't really make a difference. Okay, so that's going to give us x squared minus 3x plus 3x minus 9. Now, in this case, we have to add like terms. However, negative 3x and positive 3x are precisely opposite of each other, so we can cancel them out, which is going to give us a final answer of x squared minus 9 as the expanded form. Okay, so I've provided the following two examples for you to try on your own if you're interested. And you can pause the video to do that. Once you're all done, come back here and I will show you the answers. Okay, so to start with the red one that's on the left here, we're going to go ahead and FOIL, meaning that we're multiplying the same terms as always. So start with the firsts, and then the outsides, followed by the insides, and then the lasts. So we're going to get x times x plus 2 times x plus negative 1 times x plus negative 1 times 2, which is going to give me x squared plus 2x minus x minus 2, or x squared plus x minus 2 as my final answer. Now, for the one on the right, it's going to be the same process. So multiply firsts, and then the outsides, and then the insides, and then the lasts. Now here, that's going to give me x times x plus x times negative 7 plus negative 6 times x plus negative 6 times negative 7. Well, that's going to be equal to x squared minus 7x minus 6x plus 42, or x squared minus 13x plus 42. And if you have any questions about the plus 42, remember that a negative times a negative will always lead to a positive result. Alright, so for the following expression, you can see that this has changed up a little bit because we have a coefficient on x. Now, is that going to change the way that we FOIL? No. There's no different formula, there's no new magic that we're applying here. It's the same thing as always. So we're going to get 2x times x plus 2x times negative 5 plus 1 times x plus 1 times negative 5, which is going to give me 2x squared minus 10x plus x minus 5, or 2x squared minus 9x minus 5 as my final answer for this expression. Okay, so for the following example here, it might seem like there's nothing to FOIL at a glance, but just keep in mind that we have this squared here. And anytime that you see a term being squared, what that means is that we're multiplying it by itself. So we're going to have x minus 1 times x minus 1. And from here, this becomes a very easy expression to FOIL. So we're going to get x times x plus x times negative 1 plus negative 1 times x plus negative 1 times negative 1, which is going to give me x squared minus x plus 1, or x squared minus 2x plus 1 as my final answer. Right, now to end off the video, I want to leave you with two last examples. So I'll get you to try both of these on your own, if you're interested, of course, and come back to the video once you're all done. Alright, so let's begin with the example on the left as usual. Remember that when we square something, we are just multiplying it by itself. So here we have x minus 3 times x minus 3. Well, here, this is going to give me x squared minus 3x minus 3x plus 9, or x squared minus 6x plus 9 as my final answer. And on the right, we have something very similar. It's already in a form that we can FOIL with, which is great. So that's going to give me 4x squared plus 8x minus x minus 2, or 4x squared plus 7x minus 2 as my final answer. Right, well, thank you very much for joining me for this video, and I hope to see you again soon.